And now it's time for
a tiny bite
of knowledge.
Jodi, are you grid sampling?
You betcha.
Jodi, are you zone sampling?
You betcha.
Are they the same thing?
Absolutely not.
Let's talk about it. What is the difference between grid sampling and zone sampling? What really is a grid?
We talk a lot about these different types of precision soil sampling methods because what they allow us to do is figure out where field variability is. But let's talk about what might be a better fit and where and why. So when we talk about grid sampling, what's happening is we're basically taking a square grid and placing it over the top of the field that we want to collect soil samples for. And these are typically anywhere in size from 1 to 2.5 to 5 acres in size based on how intense you want to be, how much money you have for soil analyses, and of course your time.
So each square, each grid, 1 acre, 2 acres, 5 acres, each square is soil sampled as if it's its own field. Between 10 to 15 cores are taken within that one grid. And then that soil is sent to the soil analysis lab. And when we get those results back, we put those results into the computer, and the computer helps us map out soil analysis data. In this instance, grid sampling, it really helps us understand the variability based on the soil sampling data. It is the soil sampling data itself that explains the field variability.
Yeah. And so when you think about it, right, we're not letting the landscape tell us where that variability is. We are using the soil test results and where we soil sampled to tell us where that variability was.
So what about zones? What are zones?
So zones are very popular here in North Dakota because what it really does is takes a look at the field itself and has the field tell us where that variability is. And so we get that by looking at different pieces of data, whether that be satellite imagery data, yield data from that field from previous years. We're letting the field itself tell us where in the field areas act similarly or differently. And so at the end of the day, instead of having to take a 1 acre square and then test it to figure out where the variability is, we're letting that data from the field tell us which areas we should manage as its own zone. And so then these zones become their own fields that we manage individually.
And there's a lot of different data sources that we can use to help us understand the variability of a landscape. I think you brought up a couple of them with yield data, satellite imagery. We can use electrical conductivity layers, for example, from EC sensors like EM38s or Veris. We can also use topography data. There's all sorts of data sources, and we're able to combine those data sources in many different ways. And so in this instance, it really is the data that helps explain the field variability. And then we'll soil sample each one of those zones as if it's its own field. Oftentimes, we're at between 3 to 8 zones per field. Sometimes that depends upon how big the field is or how much variability is within a field.
Yeah, I mean, that's a big difference, right? Grid is we're arbitrarily making the areas that we're sampling or treating as its own field in these arbitrary squares. And in zones, we're creating those boundaries in those zones based on where we're seeing differences in the data. And so obviously with these big differences, there's places where grids fit really well and there's places where zones fit really well.
Grids are by far and away the most expensive and most labor-intense soil sampling method that exists. There's a major cost difference between zones and grids. Now, if you're on a small field and maybe it's going to be a better fit, let's just say you use even 2 acre grids. Let's say you're out west and you've got a 1,000 acre field and you're going to grid sample 2 acre grids on that thing. You're still sampling 500 fields within that field, if you want to think about it that way. Whereas if you zone sample it, you're going to be, maybe you have a lot of zones out there. Maybe you're up at that 7 zones per field, but you're still doing 7 zones versus 500 grids. That's a major difference.
It's a great point because, okay, yes, it sounds like 7 zones is a lot to sample versus just one composite for a 1,000 acre field. But think about how much variability is sitting there in that 1,000 acre field. So it just makes sense if we can split that field up into 7 pieces, act similarly, and that could be treated as their own fields. That's going to help us be way more efficient with our inputs that following crop year.
That's not to say that grids don't have a fit as well. Oftentimes, grids do a very nice job of defining man-made variability, such as, well, my favorite example is manure applications. If you've got heavy manure applications, it's a really great way to get out there and really understand where that manure got placed. Manure tends to be very high in phosphate, and so keeping track of that is really important.
And especially too, like in the United States where they have had a much longer history of farming and fertilizer use, it just makes sense to do grid sampling because the variability in soil fertility is not so much based on landscape as it is based on historic fertilizer use. So again, grid samples do a really good job of defining where that variability is due to man-made actions.
It's interesting that you bring that up because in North Dakota, while we do mostly zone sampling up in this neck of the woods or grass in the prairie, whatever you want to call it, I don't know. Anyway, we do more zone sampling up here. But there have been some places where grids have fit very nicely. I worked with a field that it seemed like potassium was really the big driver behind why yields were so weird out there. And yet I went out and grid sampled that field and was able to determine, because I was getting really weird results coming back on my phosphorus, I was able to determine that there were some very deficient areas in the field with phosphorus. And the geographic distribution of the phosphorus was just completely different than the potassium. And so grid sampling really helped bring that out, and it helped me manage that field better.
And not only in the eastern part of the state are there areas that could benefit from grid sampling in some areas, but there are also some issues related to pH that may benefit from doing some grid sampling. Maybe not on a 1,000-acre field, but maybe in some areas that you suspect that are lower yielding, but maybe don't know why. So for example, on my home farm out in western North Dakota, we have some fields that are low in pH. And so breaking a 28-acre field into 1-acre grids really helped us identify the really bad areas of the field that had really low pH, that it really did need more lime versus the areas that didn't need as much lime. So there are likely some applications for grid sampling out in western North Dakota as well. But to really wrap this all up, if you're in the Northern Great Plains and you really want to get into variable rate fertilizer application and you want to move from composites to something, for the most part, going to zones is going to be a fantastic first step. But just know that if there's some variability that you can't explain with your zones, maybe it's time to break out some grids and get into those areas and do some more intensive sampling that way.
And you might be in a place where grid sampling is just appropriate. And if you are going to do zones, you have to make sure that the zones are set up well. If you have zones that are not defining the field variability correctly, anything you do from that point on will also not be correct. So it's critical that you get those zones set up well.
If you know the land that you're working on well, the final zone map should make sense to you. It needs to make sense. If it does not make sense, have it redone.
Absolutely. I think that's fabulous advice right there. So in closing, grids and zones, precision soil sampling has a fit, and both methods of grids and zones, they have a fit someplace. So find one that works well for you. With that, at GK Technology,
We have a map
and an app for that.
Let the geeks at GK Technology help you with your agricultural data. Their agronomists know agriculture. When it comes to creating soils and zone maps to maximize yields in your fields, you can trust the people with decades of experience in site-specific agriculture. Everyone at GK Technology has a background in agriculture, so they know what makes a farm run, and they speak your language. The geeks at GK Technology have a map and an app for that.